Welcome to my channel. Today we will learn naive Bayes, one of the simplest and fastest classification algorithms. Even though it looks simple, it is used in many real applications like spam detection, sentiment analysis, and document classification. Naive Bayes is based on the Bayes theorem. Instead of directly predicting the category, it predicts the probability of each category and chooses the one with the highest probability. It is called naive because it assumes all features are independent from each other, which is not always true, but still works well. Naive Bayes works like this. For a new email, it checks what words the email contains, calculates the probability that the email is spam, and also the probability that it is not spam. Whichever probability is higher becomes the final prediction. Bayes' theorem looks mathematical, but the idea is simple. Prior means what we already know. Likelihood means how strongly the features support the class. Posterior is the final probability after combining both. Naive Bayes repeats this for all classes. The algorithm is called naive because it assumes every feature is independent. In real world, features often depend on each other, but surprisingly, naive Bayes still performs extremely well in many cases. This is how naive Bayes works internally. First, it counts how many times certain features occur in each class. Then, it converts those counts into probabilities. For new data, it multiplies the probabilities for each class and picks the class with the highest final score. Let's take a simple example. If historically you played tennis on sunny days 2 times and skipped 1 time, the algorithm learns these probabilities. Next time it sees a sunny day, it calculates both probabilities and chooses the higher one. So it predicts you will play. There are 3 main types. Gaussian naive Bayes is for continuous data like height or weight. Multinomial naive Bayes is used heavily in natural language processing because it works with word counts. Bernoulli is for yes-no type features. Naive Bayes is extremely fast because it only needs simple counts and multiplications. It works very well when the number of features is large, especially with text data. It is one of the easiest algorithms to train. The independence assumption is often unrealistic, and when features depend on each other strongly, the model may perform poorly. Also, when certain values never occur in the training data, probabilities can drop to 0. So smoothing techniques like Laplace smoothing are used. Naive Bayes is heavily used in spam detection, sentiment analysis, and text classification. It also works well for medical diagnosis and news categorization, because probabilities help in decision-making. To summarize, naive Bayes is one of the simplest and fastest machine learning algorithms. It uses probabilities to classify data and works especially well for text. The independence assumption is its biggest weakness, but still it performs surprisingly well. Thank you for watching. In the next video, we will explore support vector machines, one of the most powerful algorithms for classification. See you in next video.